Hi, so let's try this challenge. It says twice as old. It says your function takes two arguments, one the father's current age in years and the current age of his son in years. Calculate how many years ago the father was twice as old as his son, or in how many years he will be twice as old. The answer is always greater or equals to 0, no matter if it was in the past or it is in the future. So let's try solving this in JavaScript. And first of all, I will have to let me just solve it this way. I'm going to get the age of the dad when the son was born. So I'll just say this dad years old minus the son's years old. So if the dad is 40 and the son is 20, then the new dad age here will be 20. 40 minus 20. So I'm going to also specify when the son was born. So definitely his age will be 0 that way. So what I'm going to do next is I'm going to loop through these two values, and I'm going to increment them by 1 each time, and I'll compare them and see whether half of the dad's age is that of his son. So I can just say use the while loop, and I'm going to take this dad's age and compare it. So I'm saying while this half of this dad's age is not same as the son age, right? So if this is not the same, then it's going to increment that age and the son's age. So I'll just do plus and that of the son here that way. So once it increments, it's going to go back through the loop and it's going to compare it again, and it will get to the point where the dad's age is going to be exactly half as half of the dad's age will be the same as the son's age. So the dad's age will be exactly double the son's age. So once it gets to that point, then this will fail and it's going to now return. So I'm going to return the difference between the current age where the dad is twice the son's age, and I'm going to subtract that from the dad's real current age now, and I'm going to find the absolute of that, because we are told whether past or future, the difference is just what is needed. So I'm going to say math dot absolute, then I'm going to take this dad's current age here and I'll subtract that, say minus this dad's age now, that one. So I believe this should solve the challenge. Let's see that if it will work. All right, so that passed. Let's attempt, and good. So we've been able to solve that. But is there any way to refactor this? I think there's actually an easier way to refactor this, and that's basically using logic. I think that's just the way to put it. So how we can solve that is assuming the dad's age is 20 and is 40, sorry, and the son's age is 20. So what can we notice from this? We can see that when we multiply the son's age by 2, so that's by 2, we are getting exactly the dad's age, right? So there's a factor of 2 here involved. So let's assume in this way that the son's age is 30. So remember that his dad's age will now be 50, because when the son was 20, the dad was 40, and now the son is 30, the dad is 50, right? So what are we going to do here now? Now what we're going to do is we're going to see what exactly is the difference between the dad's current age and when his age was twice of this. So what we'll do is the same thing. We'll use the factor times 2 of this current sun's age, and that would give us 60, right? And if we take that age or 60 from this, what we'll get is minus 10. And if you find the absolute of that will give you 10. So it means that that's 50, right? Minus 10 will be 40. So it's when the dad is 10 years back, that was when he was twice as old as his son. So let's do another example here to make it clearer. So I'm going to assume that the dad now was 30, and when the dad is 30, his child will be 10, right? So I'm going to do the same thing, a factor of 2, and if you multiply that will be 20. So if we subtract 20 from 30, what do we get? 10. And it means that the dad would need 10 years more ahead to be twice as old as his son. So simply you just multiply the son's age by 2 and then subtract it from the dad's current age, and then you find the absolute. Then you get the number of years, whether in the past or present, that the dad needs to be twice as much as his son. So let's do that. So I'm just going to take all this off. It's not needed now. And even this one, I'm going to take all that one off. So what we'll just simply need to do is, we already have the dad's current age, and remember what we needed was to multiply the son's age by 2. So I'm going to take this son years old here and multiply it by 2, and then we subtract it from the dad's age, and that will be the number of years. When we find the absolute value of that will give the number of years that the dad will require, whether in the past or in the future, to be twice as much as his son's age. So let's test that, and that passed an attempt, and that passed. So we solved that in JavaScript. Let's go try that in Python. And I think we'll do kind of the same thing, just the same understanding with that of JavaScript. So what I will do here is I will just take the dad's age, that's the age when the son was born. So I will do the same thing, minus when the son was born, right? That's the dad's age. Then the son's age would be 0, right? So now we have to use the while loop, and this is more like the do while loop in JavaScript, because first of all I'm going to increment the age of the 2 of them, because I don't want it to start from 0, because definitely you can't double 0. So that's the dad's age and the son's age. Doing the same, sorry. I'm going to duplicate that. I'm going to add 1 to that, sorry. So after I've incremented that, I'll say if the dad's age, right, the half of the dad's age is equivalent to the son's age, that way. So what do? Then we are going to break the loop. That's what we will do. So we're going to break the loop, right? So this will continue to run as is true. It will continue to run, but if this condition is met, such that the dad's age, half of the dad's age, is now the same as the son's age, then it's going to break. It's going to stop the while loop, and then it's going to return return the absolute value of the that age is real age now, and that one we just incremented it to that way. So let me test this. That passed. Attempt. That passed. So basically this is similar to what we did in JavaScript, because we just found the that age when the son was born and the son's age which is 0, and we are doing a while loop and incrementing the that age and the son's age by 1 every time that we or let me say afterwards we then find out if the that age is twice as much as the son's age. And when that condition is met, it's going to stop this while loop, and by then the that age would have been set with the son's age, and then we'll take that age and subtract it from the current that age to know how many years that dad needs, whether in the past or in the future. That's why we have absolute to be twice as much as his son. So that solves that one. So the second method to refactor it is similar to what we did, where we considered that the that age, when the that age is twice as much as the son's age, there is an increment or a multiple of 2. That means the son's age times 2 is the dad's age, right? So we also need to factor that when the son is has a different age from the dad. We'll do that simply by saying 2 times that. So it's 2 times the son's age actually. Then we'll subtract that from the dad's current age, and we'll get the exact number of years that the dad will require to be twice his son's age. So let's test that. Passed and attempt, and that passed. So